Good afternoon. We are Team 7, integrated by Marco Barreto and Gary Lara, and we are going to present our final project, Delivery 7. Um, just a brief reminder, in the last part in the last delivery of the project, we decided to split the high CP and low CP values according to the mean. If there was values above the mean, there were high CP, and if there were lower, they were low CP. But in this case, in order to select the two extreme values for the CP, we decided to drop all the values between the first and the third quartile. And this led us to the next classification, which is the high values correspond to the values that are equal or higher than the third quartile, while the low values correspond to the ones that are equally or below the first quartile. Then with this classification of low and high CP, we proceed to do all the steps as in the previous delivery, which was complete the matrix, ensure that each matrix has the same number of rows, the same dimension, and also the corresponding values. Then we follow to convert the response variable, which was continuous, into a categorical into groups, which are low CP or high CP, or 0 and 1 in the next in the regression. And finally, we proceed to convert all the columns into factors and in domain variables to perform the logistic regression. Here is the code of how we convert the continuous variable to a categorical, to the high and low CP, this binary variable, in order to perform the logistic. Once with all the previous steps done, we proceed to perform the logistic regression with all the 433 variables to determine the null and residual deviances, the AIC, and the McFadden pseudo R-square, which were selected as our criteria for checking the accuracy of the model. For performing the logistic regression, we employ the general linear model function, GLM, with fixed family binomial. And these are the results. As we can see here, the regression doesn't converge at all. This is because this is because of the singularities. We can see here in the left table that we have some significant variables, but also we have another which have an NA values and this is due to that these variables are collinear with the other ones, so not all these coefficients are computed. And also this is a clear case of overfitting of the model. And we just compute the null and residual deviance. We can see here that both, but especially the residual deviance is significantly larger than the degrees of freedom, which talk us about not good fit or not a good model. And also the AIC is quite large in comparison with another models that we are going to present in the next slides. And the R-square McFadden led us to a negative value, which also confirmed that this is not a good fit for the information. Then, in order to measure the impact of each variable and select the 20 most important, or the 20 variables that have the major impact, we proceed to, from this logistic regression, order all the coefficients by its magnitude, and we select the ones that have the major coefficient value and the ones that have the minor or the more negative coefficient value, and these were selected as our variables. Here is how we perform this in code. Here how select the coefficient from the logistic regression, search for the relevant, and then sorted to stay with the low and high. And this is how it seems, the 10 most negative coefficient and the 10 most positive, and its correspondent variables.
So this time, with the 20 variables selected, we proceed to perform a second logistic regression and analyze the accuracy indicators. So this time, again, we can see that we have here are the deviance residuals. We have the median around 0. Here we have the coefficients. And in the next slide, so we have that the residual deviance is less than the degrees of freedom that we have here. And also the residual deviance is less than the null deviance, as we see here. And that means that the model is better fitted with the variables chosen than rather having only one intercept. In addition, the AIC is lower than the last time. This time we have a score of 194 against a score of 3,400 the last time. So overall, we can see that we have a better numbers for the model, for the null, the residual deviance, and the AIC. Again, we compute the pseudo R squared from the log likelihoods, and we get a score of 0.51, and it can be interpreted as the overall performance going from a scale of 0 to 1. We can use the same log likelihoods to calculate the p-value for the R squared using a chi-squared distribution. In this case, the p-value is really small, so it ensures that the R squared is a good score for the model. We also calculate the log likelihood residual deviance, and we end up with a value of minus 76.22. I'm going to get back to that value in just a second. And in comparison between the Ridge and the logistic regression, since we know that the R squared from the Ridge regression and the McFadden pseudo R squareds do not represent the same, we cannot compare them directly. Since the R square values tell us how much variation in Y is explained by all our predictors, while on the other hand, the pseudo R square tell us how much more of the variation is in Y is explained by our model with the predictors as compared to the null model. So since this is the case, we need to proceed to compare the model by using the residuals of each model. And we took the absolute value of the residual sum of squares from the Ridge regression that we have over here, and the log likelihood of the logistic regression from the deviance. The closer number is to 0 is the better fit from the model. So in the left, we have the Ridge regression residual sum square, which is 1033.7. And from the log likelihood from the logistic regression, we have a residual deviance of minus 76. But since we are only taking in contrast or only caring about the absolute value, we have a 76 here. And since 76 is closer to 0, we have a better model for the logistic regression. Just to see how our model behaves, we plot the model with the predicted probabilities. And this is the code used for the plotting the model. We get the predicted data, and from the predicted data, we rank them and we plot them, and we get this plot. So our plot looks like this, and most of the blue X belongs to the top part, as we see over here. And most of the red X belongs to the bottom part, as we see over here. Most of the stages in the process with low CP are predicted to have a high probability of getting a low CP. Similarly, in the other hand, for most of the stages in the process with a high CP are predicted to have a low probability of having a high CP value. as we see from the plot. So to get a better idea of how well the model is performing, we use the bootstrapping and try the model 100 times with the bootstrap data. Our results shows that after the 100 iterations, we get an R squared, zero R squared of 0.51. So it's consistent from the past R squared score that we had. And this time we have a bias of 0.05 and a standard error of 0.04. So if we plot these results from the bootstrapping, we get a graph like this. And we only show the 51st iterations of the bootstrapping, and we get this. So a summary from what we have is that the logistic regression performed better than the Ridge regression, since the logistic residuals deviance was closer to 0. Also, there is a higher probability of getting a low CP value. Then, the bootstrap shows that the logistic model is consistent with a low bias. This would be all from our part. Thank you very much.